going to be going over today how to utilize the machining extension inside of Fusion 360 to program parts faster, to get rid of things like quality control issues, and overall, hopefully just make sure you guys can end up making more money. Cool, so let's go ahead and jump right into Fusion 360. So out the get-go, as you can see here, I have my part set up. This was one more recently that I worked with a customer on. It's a weldment. It's a link to like a excavator arm or a trash arm or things like that. And one of the things the customer wanted to do was kind of use one work offset, just control everything, but they wanted to be able to actually go in and find both ends of this part on its own corresponding work offset for machining purposes. And then at the end of that, they want to be able to actually probe their parts, make their measurements, and adjust tool wear on the fly. So as you can see from a get-go, for those of you that have used Fusion, I've already created my couple of work offsets. I've also incorporated in here a contour for that cleanup pass. And inside both of those contours, I need to move a menu here. I actually created a tool path using wear compensation type. This is the key element here where I can actually go in, use the controller wear, which is where my probe is going to go in and actually push those coordinates. So right out the get-go, in my first operation, I would like to create a couple of probing cycles to be able to actually probe the inside of those bores. So as you're seeing me do is I have these nice blanks cut that would be part of my weldment. Maybe they're water jet, maybe they're laser cut, maybe they're just flame cut. But I want to go in and I want to probe the center of one of those using my probing tool. In this case, give me a quick second to grab my probe. So all I'm doing here is a standard WCS. However, what I want to do is I want to actually output my offset to work offset 2, which will actually be my G55. And that G55 corresponds over here on the left to my next work offset. So with that being said, is I can actually control things. So let's say this was welded together wrong. If it's out of position, we could stop, or if it's the wrong size from square one, let's just stop the machine and notify what's going on. So this is a process that you'll find yourself doing in the first setup. And the concept here is we're going to use our G54 to set the distance for our probe, and then we're going to push the results for the probe out to G55. I can duplicate this and do this for the other end, but I'm going to go ahead and now rotate down into my next setup. So the advanced probing side of the machining extension as a whole is going to actually include what's called probe geometry versus probe WCS. Probe WCS is in the base package, but probe geometry is where we actually go in and start to create our measurements. So by saying probe geometry, you're going to see this is going to feel very familiar as if it is that other tool path at the end of the day. So let's say we've already roughed out our pocket and everything. I need to go in and measure where my bearing race is going to fit. And I want to be able to measure that and maintain a tolerance. So let's say my press fit tolerance is going to be plus or minus 5/10. I can go ahead and plug that dimension in here. And with that information, every time it goes in and probe, I may want to say if it's the wrong side, I can go ahead and stop completely. Maybe that tool breaks, or I want to update tool wear based on that actual 2D contour. So now you can see it actually pulled my tool through, and I can give this a minimum threshold. So we can get really, really, really precise here, where every 2.5 is it's gonna update the tool wear, but not until that threshold is met. And you can change your error correction. Maybe it's 100%, maybe it's 50%. This is how we're gonna start to automate our process at the end of the day with our probing cycles. So now when we start to run this part, I need to move my menu again here real quick. I'm gonna go in, I'm gonna pull for my G54, and I'm gonna probe to the center of my actual drilled hole in that flame cut or that flame cut hole. We can measure that hole. We could set our G55, then come back in my G55, rough my part, cut my actual features. Lastly, let's probe those features. And with that information, we're going to plug that back into the controller automatically. So if I had to run 20 of these, I don't need to measure each one. I may not even need to do a go, no go certification, a check of this. I would still always measure the first and the last, But that way we can just concentrate on getting parts through the machine and simplifying the process on who could be loading parts, who's operating that machine. Maybe you're a guy like me that likes to program and operate. This way I can run 20 parts. The machine is trusted to do what the machine is meant to do and make its own corrections on the fly. So let's go ahead and move on to another probing strategy that's a little more advanced. If you're somebody like myself, you may have to deal with a setup like this from time to time. This is bolted down to the table. I may have a nice clean machine surface here. The issue with that being is how long could it take to dial indicate something in like this? Some of you that are more advanced programmers and machinists, maybe a couple of minutes. Maybe this was a mold that's been ran for 10,000 hours. It's warped, it's twisted. Now trying to tram this edge in or find somewhere to pull my work offset from is getting next to impossible. Well, again, in that inspection tab, you have what's called part alignment. Part alignment is a great tool to be able to go out there and base your measurements in a 3-axis, 4-axis, or 5-axis environment. So let's just say 3-axis. And now I can go back and probe just about anything and everything I want based on this part. I can even actually come up here and pull things like flats. I can pull the top of this actual egg shape here. And the more points you pull allows Fusion to actually come through here and average these points. And with the average of those points, it's going to allow me to post my G-code based on alignment. So the nice thing is here is once you go through and you probe all of your features, you actually go out and post for alignment. That will run the probing cycle and bring the info back. Next thing around is we're going to post with alignment, which means if this part was twisted 2 degrees or my entire part's off 60 thou in not just one axis but all 3 axes, it will actually manipulate the G-code as we move on down my tool paths. So this is kind of a neat feature that I found when you're going in and dealing with weird shaped parts, you're doing revisions, you're doing rework. Take a part like this out, you run it through your CMM, bring it back from the CMM, and it's wrong. Just getting it back in the machine could be a problem. So this is where we have that luxury to always bring something back, find it where it is on the table, and then run everything based on where it's located. Moving on from here, we're going to go ahead and finish this actual alignment. We're going to exit this, and we're going to start to dive into the last and final kind of advanced probing feature. That in here is going to be your actual inspect surface. The inspect surface, you're actually going to notice it looks very familiar from when I just did that part alignment. The same rules apply where I pull as many and every points on my part as possible. And this is going to utilize that probe very similar to how a CMM would work. You can set your points of data, you can actually set your upper and lower thresholds, and you can post your data, bringing it back from the machine controller again. So if you take that idea that before we machine this all, we think it's good, we take it to quality assurance comes back and says you're missing something. Well, I wasted all that setup time taking it out of the machine, putting it back in the machine, even time that I had to wait on quality assurance, where I could actually go in and do an inspect surface, pull all of my points of data, and then you have the ability to go out there and import those results back in to show you, are you within tolerance of that surface? Is your part in spec? Is it out of spec? Did I overcut? Did I undercut? Am I missing a feature altogether? Maybe I forgot to do a finish after a pre-finish on my part. I've also seen a lot of customers utilize something as simple as this, where they don't have a CMM, but they have a customer that wants to see a first article inspection. Well, why not use the probe you paid for on your machine to generate those results for you in the long run? Again, a little easier than doing the old-fashioned way with the height gauge or the micro height and filling out paperwork. We let Fusion go out and do that, and then you can actually save those inspection reports and email them back and forth to your customer, share them with a link. More of our 3D toolpaths that come in the machining extension. Traditionally, if any of you are mold makers, you make tool, die, you find yourself even doing plaques and things of that nature that work with shapes that are very organic. By organic, I mean they're just not simple square and simple fillets. They're actually very involved 3D profiles that are going to require 3D surfacing. So to most of you out there without the machining extension, you've probably been taking approaches like 2D contour. I'm a huge fan of 2D contour, or 3D contour, I apologize. I've been using this toolpath for a ton of time. That being said, is the problem with it is when you get into the shallow areas. So you get like me, you start to adjust that toolpath, you start to turn on things like machine shallow areas. However, I get nasty cusps across my part in the extreme shallow areas. So that usually leads me on to another toolpath that we can start to look at things like a scallop. Does a scallop give me full coverage? It does. It's a great toolpath. But now in my steep areas, I'm probably wasting machining time. So yes, it's an awesome strategy, but there's still drawbacks of it when you get into those steeper areas. So what I used to traditionally do is I actually used to split these toolpaths up where I can actually scallop one area, but the bad news is if you're trying to program this quick, I may now need to split this toolpath into two separate toolpaths. Because if I try to machine down here, at the same time I'm machining up here, I'm going to plunge into my part. I'm going to cause surface defects and things of that nature as we go through this part. And again, I come back with that contour forcing just the verticals. So to fix this, this is a traditional approach. I would actually take this toolpath and duplicate it. And then I would need to reorder my toolpaths. This should feel familiar. And then I need to edit one to say I need to actually start from a selected point. And maybe I start from this point and work below there. So I just get my lower versus my upper. And again, now you see I'm starting to program 3 different toolpaths to achieve what the steep and shallow toolpath kind of rolls everything up into one. So this is an added toolpath that you get. This actually comes out of PowerMill at the end of the day, where I can say steep and shallow with a tool like that, and we could go through and we could set this up. So this toolpath will look a little more complex than my scallop and my 2D or 3D contour, but it's just as simple at the end of the day, where I can do, you know, my 30 thou step down, and then I want to do a 15 thou step over. And then the neat thing is at a threshold of 30 degrees, we change those actual strategies. So if I go ahead and calculate this, we'll actually see this information start to populate and come through. And while that's loading, let me go ahead and reorder a few other things so we can keep my files nice and neat. But we're actually going to see this strategy is going to do everything in one. And it's also going to work from a top-down type of profile, which is going to make life on everybody much easier. I tend to really call this toolpath my actual Swiss Army knife of toolpaths. And in the great world of being a machinist, you can see I also made a mistake by not setting my boundaries. However, as we start to look at the different parts, you can see we scallop the top, we transition into a different strategy for the steeps, and then we transition to another strategy down here in the shallows. So that being said, let's go back and make a quick edit here. Another kind of feature of this toolpath that I really enjoy is the ability to actually say, ignore flat areas and things of that. So we're going to avoid the flat areas. I'm going to go ahead and let this recalculate. And we could take a look at this because you have things like the horizontal toolpath that's going to come through and machine everywhere flat on my model. So instead of forcing boundaries or finding myself changing chains, saying, you know, avoid this surface, avoid that surface, Fusion quickly will actually identify those areas and populate them accordingly. So things like the top of my model over here is flat, this area here, this entire area is flat. We avoided all those areas. So I'm going to go ahead and edit this one time, and we're just going to chop this down to a selected boundary. And we're going to go ahead and give that some contact point boundaries. So again, when we do a side-by-side comparison of one to the other, normally we would do that, you know, upper scallop, switch to a contour, switch back to another scallop strategy, where when we're using things like the steep and shallow toolpath, we're getting that nice upper coverage, and then we're transitioning down our part and then changing strategies again. So it's up to you if you would want to make 3 different strategies on this part or do one strategy that covers 3 different areas in one go. moving a little further on here, we're going to jump into this ridge feature over to the left to show the same kind of concept. So this part here in a scallop strategy works really well, but I'm getting a lot of weird vertical motions where I'm plunging, I'm moving up, moving down across that surface. Go in there, we kind of look at, what if I limit it to certain angles? This looks better. But then I find myself doing, again, a contour strategy to fill in those gaps when we transition from area to area. So we could do that steep and shallow strategy one more time. I'm just going to duplicate, copy and paste it, and then we'll just change our boundary. But this is where we have the option to go in and actually change, are we doing a scallop versus a parallel? Because it makes more sense in those shallow areas. And it's going to be a feature by feature or a part by part kind of decision you make. The nice thing is again, is we can kind of work from the top down, avoid collisions, avoid burying tools, causing those little burrs and issues. We'll go back now and actually swap that out. So it takes nothing more than going to your passes tab. Instead of a scallop, we could say parallel, and we can actually go ahead and add a fixed direction if you would like. This will only specify one direction, or we can allow Fusion to make those choices for us. Moving a little further along from here, at this point, we went ahead and we've kind of gone over that steep and shallow strategy from a 3-axis standpoint to be able to utilize that on nothing more than a 3-axis machine. Diving into a little bit more fun with this toolpath comes in a lot of different options in it. So for example, right out the get-go, I like to use the simulation to show this, but we can actually look at our toolpath, and something as simple as all these little dots and all these little points of reference. Anybody that's been doing 3D machining has been using things like smoothing as well as your tolerance to help fix this. You're still going to get it, or your tolerance is just going to get so large that it's almost frustrating on your part, where the actual steep and shallow toolpath uses a couple different strategies from fit arcs to evenly spaced points based on what you're doing. I really love the fit arcs over the traditional smoothing, where you just give it a tolerance and hope for the best, is because it's going to look at very similar curves and reduce the amount of points based on that curve. So let's go ahead and go back and look at our simulation. As you can see, other than my lead in, lead outs here, all these very large sweeping arcs has had a dramatic reduction in points. And as some of you may not know, those points are based off an axis of change. So the less points you can get, the smoother your part tends to get, and a lot easier on your machine to run. Again, this is kind of one of my favorite toolpaths at the end of the day. I feel that it's absolutely worth it inside of Fusion 360, because you could come back and you could say something like, instead of smoothing fit arcs, we could do evenly spaced arcs. Evenly spaced points will actually just give you that kind of a traditional approach, not the same as your tolerance where you allow a deviation. We can actually say from end to end along that toolpath, what is our maximum spacing? Do we want to increase? Do we want to decrease that? Do we want 1,000,000 points on something so simple? Or do we want, 10 points? This is something that, again, I find myself using constantly when it comes to doing 3D machining, mold making, even using it on a simpler part, kind of like this clutch cover. I have a few customers that use steep and shallow to be able to do vertical walls and flats, and then this taper here all in one shot, just because they treat that scallop toolpath as a horizontal. So we're going to actually circle back to this part here in a little bit, but I'm going to transition away from the steep and shallow. Oh, my fault there. I hit the exit button. We're going to transition into a few other tools that I don't think I could live without in machining after having them. And it can be as something simple as a 2D contour on your part. So let's say I just want to cut around the outside of my part, and I want to go to model bottom. So I know some of you out there are probably going to critique my terrible choice in tools here. This is why we're just demonstrating the possibilities. So just like that, I'm hitting my clamps. I feel like tie downs, clamps, jigs, fixtures are a huge part of everybody's life. Well, how do I avoid those? Again, traditional approach, I can go back to my setup. I can edit my setup. I can add those fixtures in there, kind of play with this more and more, or I can do what I prefer, and that is use trim toolpath. Well, trim toolpath allows me to quickly define boundaries based on areas that I don't want to machine. So in this case, I can actually get away with a rough estimate of where my clamps are, because we all know those clamps aren't going to be exact to where they're modeled right now. But I can actually add in a few boundaries here, and then I can use the outside or inside strategy, or both strategy. I love the both strategy here, because even though we machine around the outside of this part, I need to come back and still machine those little segments. So just with that, we could actually skip over each clamp around my part, and maybe my clamp isn't exactly there, right? I can always go back and edit my trim toolpath, and I can drag and drop those points to wherever I want them. I can add more points. Let's say for some reason the operator actually put this clamp much more this direction. So we're going to change this on the fly, and it's going to automatically update my toolpaths. So again, we took a standard 2D contour around my part. We split it into a outside of the boundary area and an inside the boundary area, because we do that first stop, then we move our clamps, we come back and remachine those areas we skipped, all very quickly by dropping a couple of trapezoids. I remember back in the day when I used to have to go back to design, create boxes, come back here, select those boxes, and it was just a painful workflow that I had to live through until this toolpath actually came out and allowed me to start machining. I'm going to go ahead and check my questions again. Does anybody have any questions leading up to any of this? Doesn't look like I got any more questions coming through. Give it a couple seconds here, and let's go ahead and jump back to Fusion 360. So there's another side of this toolpath. So not only do you get the toolpath trimming, but you actually get the delete passes. So if we go back to the scallop toolpath, as most of you know, we could always set a bottom height higher or just below the profile that I'm working on, but I can also do what's called a delete passes. Well, what a delete passes will allow me to do is quickly come in and grab a section of toolpath and say, okay, and just like that, I can delete out whatever I want on that toolpath. You can go back, you can edit this after you've done it. So you're starting to see a timeline almost like the design workspace, where maybe I don't want to do the passes, I just want to do certain segments. So let's say we only want to do a couple of little segments of this toolpath for some reason. So let me get zoomed in here and grab every little line segment we're getting. You could do this with your lead in and lead outs. We can modify more and more of this toolpath as we need, but this allows you to go in and quickly pull out little sections, or if you get those weird little waterfall effects that happen on your part, you're able to go in quickly and change those. You could do a few other things with this that is great at the end of the day. You could actually do a window, drop a window quickly and grab all those profiles and remove them. This works with deleting the segment of the actual chain or the chain itself when it comes to the toolpath. This is very handy when you're doing 3D surfacing. You could spend an hour modifying a toolpath to get rid of one little section, or you could do like I do, come in with the delete toolpath and actually remove that segment as we go. A few more things that I love about the combination of these two is the fact that I could actually go in and I could do a trim toolpath here. I can pull a box based on that part, do things like both. So this doesn't just work in a XY plane, it works in a Z plane. So splitting something like that steep and shallow strategy, I start from the top of my part and I start to work down. Well, this is where the last option that kind of comes in this area comes in, where we can go in and we can modify and change our tool on the fly. So I now took a tool path, split it into two segments, which a lot of you may be chuckling right now that before I was telling you, let's get 3 into 1. And then I can change things like the tool length so that I can use a longer tool. Again, making programming easier, not having to rely on the math. We can do this with a few simple fields inside of Fusion. I'm going to go on to my next part here. We're going to ramp up this a little bit more. So let's go and now look at a nice little headlight mold that we have here for a customer. So this is where I can't brag about the steep and shallow toolpath enough, because in an environment that requires 5-axis or even 4-axis, we utilize that same toolpath to be able to control 3, 4, and 5-axis machining. So let me pull in an end mill here. Let's just do a little section here. So now we're going to take what would be normally a 3D toolpath and turn it into a 5-axis toolpath. So if I was only worried about this internal cavity here, I have that ability to do everything the same as before. Let's just say we're working with a 50 thou step down, 25 thou step over. And for those of you that don't know, what you do the first time when you use this, calculate it as 3-axis, and then we'll come back and we'll add multi-axis to it. That way you don't spend a lot of time regenerating toolpaths to just make sure that you're hitting all your surfaces correct. So that's looking pretty good. I didn't turn on contact point boundary, which would explain why we're not going all the way to the bottom of those fillets, but that won't really affect what we're doing here. So let's go back and edit this. You're going to notice this is the only toolpath that has a multi-axis section. Well, this is where we transition from a vertical strategy, which is 3-axis, to being able to do full-on multi-axis. But it gets easier than that. So we do have the ability to tell Fusion, I want to set my tool to a certain lean, lead. I want to go to, from, points, and curves. But we also have advanced collision avoidance based inside of this toolpath. So if you're somebody new to 5-axis machining, I can go ahead and turn on collision avoidance automatic and simply say, okay. And what now is going to happen with this toolpath is we're going to go in and we're going to calculate. If any of you have used the multi-axis feature on 3D Contour, the same kind of system is happening here. However, it's going to be a much cleaner toolpath. Again, we're using multiple strategies combined together here to be able to do this. So we're going to go ahead and let that calculate, give it a sec. That's the automatic coming through. And right out the get-go, you notice my tool is still vertical. But from a simulation standpoint, let's go ahead and turn that back to tail so we can see this, is if I hit play here, that toolpath starts vertical, but as we get down in our part, we're going to start to get toolpath lean. And now we're actually in that 5-axis environment, back and forth that surface, to be able to clean that all out. And as we get deeper and deeper, Fusion's actually recognizing that tool holder and checking for clearance all the way around that part. So now we're utilizing the tool definition, we're utilizing automatic collision to very fast come in on what would be a weird or a strenuous internal pocket to clean that out, and not only clean out just those vertical areas, we actually were cleaning out that upper area. And as we get down to the bottom, you'll see we go back to that scallop strategy to clean up our floors and make life easy on everybody. So you can dive into this more and more. And one of the great things is we're actually going to be doing training on Monday, a 4-hour training course. And then I believe the 8th of September, we're also, which is a Wednesday, we're going to do another training section on how the machining extension works. And you're able to enroll in that and be able to utilize the machining extension and play more and more with these toolpaths, diving deeper and deeper, learning, at what time and what scenario do I utilize the multi-axis feature? Do I need to do collision avoidance? Should I actually set limits to my tool so that I'm not undercutting or upcutting into my part? We are doing a course, like I said, on Monday, and then we're doing another one on the 8th. It's $95 to register. That includes the machining extension for the training to go through this more and more. I'm not going to say that it might be left on for a few weeks after that, but it definitely gives you plenty of time to utilize it and make a good decision on whether or not it's something that you could see useful in your business. So again, as you do have that ability to limit your tool, we can come in and say, don't go further than 45. We've really simplified the Fusion software to be able to make 5-axis machining much easier on anybody and everybody. I have a lot of people that may come in with this exact strategy and say, I only want to do a vertical area. And because it's so simple to do it with the steep and shallow strategy, why not use it to your advantage? So again, instead of using the little actual curved areas or the shallow areas, we could do things like use that automatic control to wrap around my part and machine different features or different surfaces or blend surfaces, and letting the software do what the software does best, think about it for us, making my life much easier at the end of the day. Anybody have any questions on any of this yet? So again, as you can see here, we could go ahead and simulate this. We get that vertical path back and forth, but then now we're starting to get our tool leaned out more and more as we work down our part. And again, as you can see, we may have got a little bit of funkiness in my tool path up here at the top, right? All those little line segments that are a waste of time or probably not touching anything, we now use a combination of delete passes, come in, I can grab those little segments and remove them directly from my tool path and save a ton of machining time instead of trying to adjust top height, a bottom height, and all of that fun stuff that most of you have probably been doing for some time. Another extremely powerful feature of Fusion 360's machining extension is what's called hole recognition. For some of you looking at this part for all these vents, we're going to come back to these in a moment, but I like to start a little simpler than that on this clutch cover. So I know none of you have the print in front of you, but in short, I have two different sized holes. They're drilled, they're tapped, they're through holes, relatively simple. I can actually go into my hole recognition, and very quickly, hole recognition just saw 2014, that's a quarter 20. So if I go to spot drill tap through, it automatically recognizes my quarter 20. And then my 257s, which would also normally be a 5/16/18, but maybe they're actually metric M7 by 1 or something of that nature. I have the ability to change these different things or even go back and just say, you know, maybe this is a reamed hole for a pin. Quickly, I identify my holes. I can hit OK. Fusion's going to go through and spit out my tool path. So one thing is that I don't have a reamer in my library. Had I had a reamer, this tool path wouldn't have an error. But in about 20 seconds, I created 6 tool paths with spot drilling, drilling, and tapping, all based in that tool path in a 3-axis environment. So if you're somebody that's doing a lot of drilling and tapping at the end of the day, I would highly recommend having a feature like this. And if you're somebody out there doing 4th axis and 5th axis drilling and tapping on a part like this, it's one of those tool paths that I can't believe I ever used to live without it. Is I can come in on a part in a 5-axis environment and say, well, it's only seeing my vertical holes. Okay, so let's go ahead and transition and say, first off, I don't want to limit to my setup plane anymore. And I can actually set angular limits to control this. But now, as you see, all these holes on this part have actually came through for my recognition. So I can go through and adjust all of my holes, or I can hit OK because I'm happy with those strategies. This is now going to take a few seconds because we're actually calculating, I think it's just under 100 holes here. I'm also streaming live video to the internet. As you can imagine, that takes some processing power. But it's going to spit out all of these holes in all of my drilling cycles, still within a very reasonable time frame. So for some of those out there, this list is gigantic. So let me get down to the bottom. That is a total of 92 operations. So spot drills and drilling or simple drilling, whatever way you look at it, I did 90 plus holes in less than 60 seconds. And in a 5-axis world that some of you may be making a ton of work planes and trying to go hole to hole to hole to hole, hole recognition will also utilize any templates that you've been creating in a hole template environment as well. This is, again, I can't stress enough that if you're somebody that's just really trying to get parts out, the machining extension is going to speed up that workflow and make it better. I'm going to go ahead and check my chat here real quick again, see if we have any new questions roll in. Feel free to ask away. So is there an option to use a cut tap versus a form tap? So when I do this actual hole recognition, I choose what library that comes from. So if you have a library and it's strictly just form taps, then it'll pull form taps. The same thing with the drilling cycle is I can choose what drills it's using for that actual operations. So again, this is customizable. Another thing to keep in mind that if I had to go through and do this for each tool path, I'm going to find myself creating or utilizing tool orientation, picking that face. nothing's to say that you can't go back and pick one of those tool paths and edit it even after the fact. Or you can take a big section of these and drag and drop them to different operations. Once they're created, they're fully manipulative, fully editable, and changeable. For any of you that are actually interested in the extension, you have the ability to always go on and look at the machining extension and see what's in it. That's right, I forgot additional tool controls. We'll visit that one here. But I just wanted to circle through this list to, again, kind of give you all an idea of what's all in this list. So we'll start from the bottom and work our way up. The things like the toolpath editing. So the delete passes, the trimming of the toolpath, and the change tools without recalculating toolpaths. Those were all things that are great on manipulating your toolpath after it's been calculated. Again, I don't think I could live without those. Moving up a little bit, that steep and shallow strategy actually also includes the ability to do 5-axis collision avoidance. That's built into that toolpath directly. You're getting all of this in one package. The rotary strategy, I'm not actually going to touch on today. The rotary, a lot of people think they need this because, oh, I have 4th-axis milling. Well, this is actually for non-geometrical shapes, and it gets a little funky. So Fusion by itself will do 4-axis work positionally. It's when we start to get into the fun of live rotary rotational work, and that's where we can use that rotary strategy. And by all means, I'm going to have my email up here shortly. I'm going to throw it in the chat. You guys are more than welcome to reach out to me directly and ask me about these toolpaths and say, hey, you know, is this something that I actually need for this part or not? So surface inspect, the probe geometry, the hole recognition and part alignment, the advanced probing package that comes in here is all that stuff that we started with at the beginning of this demonstration, from aligning your part to picking up your features, recutting profiles, all built into this package here. And then lastly is that additional tool controls for tool orientation. So this is one that, again, I don't know if I could live without this. If they ever got rid of the machining extension, I don't know if I could still use Fusion at the end of the day. But for most of you out there that are using 2D toolpaths, say for bore, for example, or using the 3D with tool orientation, when I turn on tool orientation, you're going to notice mine looks a little more different than normal. In this case, I lied to you because 2D toolpaths don't actually do this. Let's go back to a 3D toolpath. So let's pull a scallop toolpath. When I turn on tool orientation inside of my 3D toolpaths, I get the ability to turn and tilt my tool based on what's going on. So if we wanted to very quickly just say, you know, I want to do a selected boundary based on an area, and I want to do positional work. So I actually want to use the edge of the tool, not the tip of the tool. I can tilt that tool angularly right here in real time. So if I wanted to go ahead and say, you know, negative 15 degrees, I now have a 15-degree tilt without creating work planes, without trying to find geometry to select for machining that surface. So let's go ahead and bump this down to 030 and let it calculate. So that additional controls will make your life night and day difference. And the additional controls also works in a 4-axis environment. But to fast go in, tilt the tool to get off the tip of the tool, or to try to find a feature or machine a feature at a weird angle, I don't have to create work planes. I don't have to create sketches. I have that ability to very fast go in and tilt and turn that tool to get it to where I may need it to actually work and do what I need it to do. And again, we can actually twist this now and very much get off very weird angles if I know what that angle is, or I'm quickly just trying to get a good tool path out of Fusion 360. We are doing a training course Monday. It is a 4-hour course. It's only $95 per student. This allows access to the machining extension. It allows you to learn it, to ask questions, to fully understand that. Again, this is a course that we're offering $95 for people to come in, learn the machining extension from an expert user like myself, being able to sit down, learn those tool paths, and fully implement it in a 4-hour series. I don't think anybody does a training like this at this cost, so it may be valuable to be able to jump in, and after the fact, like I said, is you can make a decision. Maybe you want to add the machining extension to your current workflow, or maybe it's not a fit for you.